Hello everyone, good morning. Welcome for coming to our session. Our topic, skin in the game. Skin in the game is not about play game. It means you should get your hands dirty in real world events. Just like the data flows global memory say, exploitation become bug dependent. I like it because the community exploitation is more hard. So you need some logical bug to use it. And we are from Pangu team, and my colleague and Ling and I focused on mobile security and system security. And if you want to talk about anything security related, let's grab a coffee later. Yeah. And today our Adreno reveal about around 3 types of GPU. Is Mali, Adreno, and PowerVR. And finally, we will talk some work in the future. And in the mobile GPU architecture, the attract surface like framework, driver, and firmware. There are so many areas to explore. But today we will focus on the IOMMU, the input-output memory management unit. It is complex and fragment structure. Enable powerful, but it's hard to define the exploits. And our discussion is not about the full future of the IOMMU vulnerabilities or our discoveries. Instead, we will do to talk how difficult and how different mobile GPUs inherit property and lead to distinct exploitation technique and tracking condition. Untapped, only by deeply understanding its operational logic can one uncover latent vulnerability. And how is the IOMMU? Like for CPU side, the CPU accesses physical memory through virtual address using the MMU, and it's a memory manager unit. It's only for CPU, and the peripheral device traditionally can't use MMU, so early device allow the device to access physical memory by DMA, but the DMA is not secret. The Apple is demonstrated yet, and the solution is use IOMMU. You hardware component enable device to access memory through iOS devices, similar to how CPU use MMU. And in ARM, IOMMU is called AMMU, but we will also see IOMMU in the next. And the first chapter is Mali GPU. I think in Mali GPU, the memory is for operation. The first is import. The import is GPU can import CPU memory through the CPU space and the next is mainly a lock. A lock is mainly can allocation the memory by itself, and the third is alias. Alias is mainly can repair the mapping of exist lock memory by the other regime. And the next is jet. This jet is not the jet in the browsing. I think it maybe is a memory to designed to accelerate memory to allocation and now during the allocation memory, I think it's not worry that physical page allocation released on nets rather than the NR pages, because the page will release the nets, and in the future you can global by the physical page by NR pages. And the next a local memory from the local, you need use the mmap syscall can allocate the word ratio, and from this type you can use the memory by CPU side, and the mmap syscall you can release all the memory by this single syscall, and it has 4 steps. By the one, you can unmap the CPU size, and the 2 you can release the you can unmap the GPU size, and the 3 you can release the GPU ratio, and the finally you can and finally you can release the all physical page to recycle. Yeah, and in the import, you have 2 different import, and the first is the immediately import. You can immediately has the memory, and the next is the delivery import. You can go to the memory at the later, and in the this, so the memory is only to the data import, and this is both problem in one, or the one into both problem. What's this? Because because if there is a problem, 2 will play together, and make it easy to make up for one and forget to the other. Yeah, in the history there is one problem, and the paired two plays. And the next is the alias, and the alias is it can map multiple local memory replied at the same time, and there is also a high incidence of vulnerability, and or it is one of the common methods to use. And the next is and we'll go to the key area of my GPU today. During the initialization process, it is one thing nothing that there are 3 lists, and the team level placement, and the series is manage the GIT memory life cycle. And you can see the JET memory is also has two methods to manage. The first is the JET new. I think is you can allocation a new region to managing the GIT memory. And the next is recycle. I think is the JET future. You can recycle at the last you free the JET memory to the list, and now you can recycle it from the list. And you can see the JET left. You can free the JET life cycle. It's only have 4 steps. At the one is you can unmap the GPU recycle in the JET active head, and from the JET active head you can put it in the JET pool head, and the JET pool head is not free head. You can also recycle the JET regime from the pool head to active head, and the finally it may be you can maybe use some like in Linux like some Hanqin triangle, or you can put it to the JET disk drive head, and if you put it in the disk drive head, you can free it to the system, and it cannot recycle by the JET. Yeah, and and we will talk to the CVE 2022 38181 first. In this problem, I think the main problem is it doesn't difference between JET and the normal allocation, which leads to it have mutual exploitation. But I think among them, the most economical methods is by manual mode, and the risk between JET allocation and the K-base commit factions, the resource and the improvement through GPU VM lock. I think it is very simple. So, what can happen? If the normal situation is like the left picture, and the vulnerability situation is like the right picture. In the right picture, you can see the page table and the pages address is not same, and there is no mapping address and no pages address in the page table. Yeah, and let's put it a sense for now and check out the next one. Next one is the CVE 2023 6241. Yeah, in this way, it has a risk between the JET allocation and the K-base MMU fault. The K-base MMU fault, I think it is in the GPU command motion, and it is also a easy risk because it has the GPU VM lock increases the rate. And what will this can lead to any problem? And like this picture, in the left, the picture is the normal area, and in the left is the it is different from the page table and the page area. There has a refill mapping and no mapping area in the page table, and we will see the no pages, and no mappings can use this to something. How to exploit it? If you use some common methods, I think it is difficult to use. But if we look for the K-base MMU tear down function, you can see this function has a factor. The factor is if there is a hole in the PTE or PMD page table, it will scale the all page table entry language to the next. I think this picture is for the eventually, and can use the GPU device so quickly. But in this vulnerability, it may be a problem, and you can see this picture. If we have a region PTE at the first, and I record the risk ratio to the second, so we can skip some veiled PTE, and finally we can get a page UF in the finally. And the next is CV 2023 6241. In this picture, you can see if we allocation the second filter in the first, you can, and the second you use the team level to free the allocation regions. Now you didn't free all the memory at jet free. You can continue the memory large to free, so you can faster in the no mapping to free. So you also can skip some well-done PT in the K-base MMU tear down. So you also can continue the page UF in the field. Okay, but in the nowadays, Mali GPU considered the efficient, but in secondary tear down factory, and it will check every PTE to free. And the second chapter is Adreno GPU. Yeah, the Adreno GPU, I think its memory management is easy by Mali GPU, and I also think it has import, allocate, and the VBO. And the VBO, I think, is like the Mali GPU alias. And you can compare them with similar components for the Mali GPU in the next. And in the Adreno GPU, I think you can see the allocation is for the thing and the different between the GPU address and the CPU address. And the something maybe serious like the Mali GPU, so we can quickly with it. And the some different is the ML map with the allocation, because you can you use the ML map the first, you only unmap the CPU side, but you should use IO control syscall free to free all the memory by the GPU, by the CPU, and the physical pages arrays. So it's different from the Mali GPU. And in the import, I think it may be the something different from the Mali GPU is different need mmap the second. It can only mmap 1.4. It can use the it can use the same address or the different address from the CPU or GPU, but the Mali is different, has this fixture, and he needs some like immediately and the delete map to the GPU. And now this is the key area today is the VBO. And in the VBO, it also has two methods to use it. The first is the I think is the 0, is because it can map the 0 page and the first. And if you need some repair allocation memory, you need the use it for the after. And the next is I think is the unmap is in the first you didn't need map something, didn't map the 0 or the anything, is only the map the mapping in the GPU manager and do nothing. And the next is also the VBO bundle. Is you can get the children offset and the larger, and you can use it to the VBO offset and the last. You can it is like the earliest. So I think it is theory between the alias and the GPU alias and the Mali alias and the Adreno VBO. Yeah. And let's we see the CV 2023 33107. It is a inter stick flow. At the first, it is the insert step. Is look at the left. It is a page table arbitrary, and now I want to insert the node 3 to the tree. So the but the node 3 the size is so large, and in the transfer to in the right black tree transfer, it will in the first, and this problem is arrow. But you use this arrow position, we can also the second race second in the right second, it has we can insert the node 4. The node 4 is in the left behind, and this problem is also error. And what problem will be happened? And the one is the node 3. How he will be has the numerical error in the node 3, and the node 4 he will happen the math error. And the important is the node 1 he has freed one page in the head. Yeah. Okay. And the next is we'll think the CV 2024 20072. And in this what problem has happened is in the VBU entry. If the VBU entry we can allocate a sign as the all GPU memory region. It will be having something, yeah, because the sense is wipe the all GPU memory, so it can overflow the noble Adreno allocate region and the red region, and we can use it the VBO offer and the hidden and the VBO last is in the children region and he will has overlap, and in the overlap we can free it, so we can also have the page UF. And why the page can be UF? Maybe in project 0, the gen say the page will be UF, but in the but in the Adreno is KGL MLU on map. It is not has checked the return code, so he will also process this free, and the next will free the physical page sense. So we'll we can use the page if, but we can change it in the on map. So this problem is the interrupt. But I think there is one more thing. What is if we use it in the map SG, and there are two ways from the Adreno and the links. In the links, it is not a problem because it in the ARM map pages it has not anything can use it, but in the GoTo the ARM map SG, in this function the init PTE has the enable error, so you can free the recycle PTE. And the next, the IOMMU user, there is also has a different from the GoTo and the links. In the GoTo, he will to check the PMD level to skip the hole, so he can avoid some hole in the PMD. But I think since GoTo has started to process logic like this, it should be handled in the full, because it can use in the PMD or the PTE and the older page table, but it only use it in the PMD. So he also like can use the fixed code like the Mali GPU above, because Mali GPU or checked all the PT holes. But if I think because the Gosong can fix this problem is use this commit, but this commit I think is a dirty code because he can't free the physical pages at first. He must free the page, physical page after you close the FD. You can close the FD, so he can also close the physical pages. If we want to close the physical page at the first time, he can't use it. Yeah. And the second, the next part will be talk with my colleague Ling. Yeah, please.
Hello everyone. Next part I will introduce the PowerVR GPU, IOMMU and its issue. So when we need some GPU memory, we first need to create a context. And thus we can isolate the GPU memory space for each processes, just like the CPU memory isolation. After that, we create some heaps. Each heap has its own functionality. Next, we create a reservation with a range, which means we will use that GPU memory later. Here comes the key part. We then create a PMR, which stands for physical memory resource. The PMR page here works as the shared memory between the CPU and GPU. On one hand, we call IOCTL to map the PMR to the reservation, and we can access the page from the GPU side. For example, we can use OpenCL to access that memory. On the other hand, we can call the mmap syscall to map the PMR to the user page. So now we can access that page from the CPU side. So now let's dive into the GPU MMU and talk about more technical details. So normally, PowerVR's page table hierarchy consists of 3 levels: PC, page catalog; PD, page dictionary; and PT, page table. Additionally, PD here refers to the actual data page. When creating context, the driver creates MMU context structure. MMU context contain a top level of MMU level info struct. The MMU level info struct contain a lot of entries pointing to the next level, which looks like a page table and works like the page table when the driver set up memory mappings. Therefore, we just call it a software page table for convenience. Correspondingly, the upper page table is called hardware page table, and it is used when we read or write certain GPU memory from the GPU side. As the figure shows, here the top level page table is being created. When we create a reservation, the driver will create the PD and the PT page table if there is no such thing. Also, both software page table and the hardware page table are created. What we should pay attention to is that the PT entry is not set. So how can we set it? When we call IOCTL to map a PMR to the reservation, the driver will look up the software page table starting from the level PC, followed by level PD and then level PT. Then it will find the hardware page table PT by memory descriptor and will locate the exact PT entry. Once found, the driver will set the physical address of the PMR page to that PT entry. In the end, the GPU mapping of the PMR page is established, we can access that PMR page from the GPU side via OpenCL, and since the page is a PMR page, and the PMR page can also be mapped to the user mode via a map. This page now becomes a shared memory page. So now let's talk about CVE 2024 31333. It's one of my findings and is a GPU MMU related vulnerability. First, we observed that when creating a reservation, the ref count in the software page table is initialized to 1. When we create another adjacent reservation, the ref count increments to 2. What's more, actually the PowerVR driver allows creating multiple reservations with the same address. In other words, if we create n reservations for the same address, the ref count becomes n, like the figure shows. Since the ref count is implemented as a 32-bit integer and there is no check for it, this is a potential integer overflow vulnerability. We can intentionally create a large number of reservations to overflow that ref count, thereby compromising the life cycle of the software page table. As a result, if we release one reservation, it will trigger the release of the software page table and its corresponding hardware page table. Once the ref count reaches 0, the driver assumes that the mapping and the related resources are no longer in use and frees the memory. According to the PowerVR logic, there is no explicit reference like dangling pointer because of this. So it is not a traditional UAF. There's no memory corruption. However, there's many reservations with empty MMU mappings. So from an abstract perspective, reservations still implicitly reference the original valid MMU mappings, while it no longer exists. Therefore, this issue is a logic use after free vulnerability. To exploit this vulnerability, we allocate a reservation B that satisfies specific conditions below. This action sets the corresponding software and hardware page tables, which are later used to construct the final page table confusion. Next, we map a PMR to the address A. From the figure on the right, the level PD refers to the software page table at MMU level 2. And PDE refers to the hardware page table at MMU level 2. The driver first looks up the software page table at level PC, gets an entry, and obtain the address of level PD. Since this entry is 0, the driver takes the yes branch and treats PC as PD, leading to the lookup of level PTA. Actually, level PTA ends up pointing to the level PTB, causing a confusion between the page table levels. Finally, the driver uses memory descriptor at level PTA to locate PTA, which is actually PDB, and update the corresponding entry. At this point, PT is a page table residing in a PMR page, which means we can modify the hardware page table from the CPU side. Now we can forge a PT entry. The full mapping is set. We can access the physical pages from the GPU side. Thus, we achieve arbitrary physical page read-write access. But there is an out-of-memory challenge in this scenario. Upon analysis, we found that each reservation allocation consumes 128 multiplied 3 bytes. Therefore, to trigger an integer overflow by allocating 0x10000000 reservations, it would require approximately 1536 GB of memory, which is clearly impossible on mobile devices. However, after further analysis, we discovered that the size of each reservation can be adjusted such that it exactly fills up an entire page table PT. We specify the size as 0x200 pages. This causes the ref count to increment 0x20 times for each reservation. As a result, to trigger the integer overflow, we only need around 3 GB of memory, making the attack practical on mobile devices. Here comes the patch. The patch introduces a check to ensure that the ref count holds a valid value. Additionally, we observed that the map operation is relatively fragile. In fact, this weakness in the map logic was previously highlighted by John Hall from Project Zero in another vulnerability report. However, the PowerVR developer did not take this issue seriously until I report this vulnerability. As a result, the new patch enhances the security by explicitly checking whether the software page table entry is nil during the map process, rather than just assuming that every reservation has a corresponding IOMMU mapping. In a word, this patch hardened the map operation with an acceptable performance overhead. So here's the conclusion. First, there is a Mali GPU exploit. Okay, we get root. And there is a PowerVR GPU exploit. So it iterates too much time and to achieve integer overflow. Okay, we get root again. So private IOMMU introduced some weakness. There's too much assumptions during the process. When the assumption gets broken, the security module may get broken too. And how can we balance efficiency and security? Can we introduce some like hardware mitigation on the GPU? That is a great topic for the further research. Okay.
Okay, and for the future work, because the future work we will not we see can use the DeepSync and I just to ask for it, and he has the answer for me, and let me see.
To address GPU IOMMU efficiency security conflicts. 1. AI-enhanced chips. Develop smart IOMMU hardware with embedded AI for real-time policy adjustments. 2. Heterogeneous virtualization. Adopt resource pooling architectures, for example, Huawei GPU tech for isolated security domains and flexible compute allocation. 3. Task-driven protocol stack. Implement Linux kernel-based mode, switching relax isolation during training. Enforce full protection for inference. Combining hardware upgrades and intelligent scheduling achieves Pareto-optimized security efficiency balance.
Maybe his word is so long, but I think what is the skin in the game? This name is I know it is from the book name from Tarabu. So I think I believe it is if you want got a benefit from the uncertainly cyber world, you need skin in the game. Thank you.